People talk about time as if it's a thing that moves. They say, time flies, or time drags, or I don't know where the time went. And everyone nods because it feels right. You wake up in the morning, the day carries you along, and before you know it, it's nighttime again. It feels like you're standing still while time rushes past you. That picture is very seductive. It's also the first thing we have to be suspicious of. Whenever something feels obvious, physics teaches us to ask a very annoying question. Is that how it really is? Or is that just how it feels? Because there's a big difference between experience and explanation. Take motion. When you're sitting in a train and it starts moving smoothly, you don't feel motion at all. But look out the window and the whole world seems to slide backward. Your sensation is not telling you the truth about what's moving. It's telling you something about your frame of reference. Time is like that. We say time flows, but try to pin that down. Flows how fast? 1 second per second? That's not an explanation. That's just repeating the same word and hoping it sounds meaningful. It's like saying a ruler measures length at 1 inch per inch. It doesn't tell you anything, so already we should be uneasy. Now here's a useful trick. When you think you understand something, ask what it does. Does time push things? Does it make atoms decay? Does it shove you from youth to old age? People talk that way, but it's sloppy thinking. Milk doesn't spoil because time attacked it. It spoils because bacteria multiply and chemical reactions occur. You don't age because time is dragging you forward. You age because your body is a complicated machine undergoing physical changes. Time isn't causing these things. Time is just how we label when they happen. Think of a ruler. A ruler doesn't stretch objects. It doesn't compress them. It doesn't make them long. It just lets you compare lengths. Time works the same way. It's not a force. It's not a substance. It's a bookkeeping device. So what is time? In the most stripped-down sense, time is how we order events. This happened, then that happened. Earlier, later, before, after. That's it. No river, no conveyor belt, no cosmic metronome ticking away behind the scenes. The reason the flowing time idea feels so convincing is that things are changing constantly. Your body is changing. Your thoughts are changing. The room is full of microscopic motion, and your brain stitches these changes together into a story. The story feels like motion through time, but the motion is in the processes, not in time itself. A flipbook doesn't have pages rushing past a stationary character. The picture changes because each page is different. If nothing changed from page to page, there would be no story and no sense of movement at all. So here's the first small but crucial realization. Time doesn't flow past you. Events happen, and you are one of them. Once you see that, the question, why does time move forward, starts to sound a little strange. Because before we ask why it moves forward, we have to ask whether it moves at all. If time really has a preferred direction, if it truly moves forward, then you would expect the laws of physics to know about that. Somewhere in the equations there ought to be a little arrow saying, this way only. So let's look. Take something simple. A ball rolling across the floor, slowing down, coming to rest. You watch it happen and you think, of course, that's time moving forward. Now imagine filming it and running the film backward. The ball starts at rest, speeds up, and rolls backward across the floor. That looks strange, but here's the important part. Nothing in Newton's laws forbids it. The equations work just as well backward as forward. If you reverse the velocities, the mathematics doesn't complain. The laws don't say, no, that's illegal. They're perfectly happy. Try another example. 2 billiard balls collide. You film the collision. Played forward, one ball hits the other and they scatter. Played backward, they come together and separate again. If you didn't know which way the film was running, the laws of physics wouldn't help you decide. This is deeply unsettling. because it means the most basic rules we know do not distinguish past from future. And it's not just classical mechanics. Electromagnetism works this way. Quantum mechanics works this way. Even the fundamental equations that govern atoms and particles are, for the most part, indifferent to time direction. Flip the sign of time, and the equations still make sense. So where exactly is this arrow we feel so strongly? People often say, well, things slow down, things wear out, that's time. But slowing down happens because of friction. Wearing out happens because of interactions with countless unseen particles. Those are extra details, not time itself. At the microscopic level, the level of atoms bumping into atoms, the laws don't say which way is yesterday and which way is tomorrow. This leads to a very important distinction that people almost never make. There is a difference between laws and situations. The laws tell you what can happen. The situation tells you what does happen. The laws allow a pendulum to swing either way. But if you see a pendulum gradually coming to rest, you know something else is involved. Air resistance, friction, energy spreading out. Those are not violations of the laws. They're consequences of having many interacting parts. So the puzzle sharpens. If the laws of physics don't care which way time runs, then time itself cannot be the thing forcing events to move forward. The arrow we experience must be coming from somewhere else. And that's the key realization. The direction of time is not written into the rules. It emerges from how many pieces are involved and how they're arranged. This is why it's so dangerous to trust intuition here. Our everyday world is full of friction, noise, heat, and complexity. We never see the clean, reversible cases, so we assume reversibility is impossible. But physics says otherwise. So here's the second aha moment, and it's a big one. The fundamental laws of nature do not prefer the future over the past. If time seems to have a direction, it's not because the universe told it to go that way. It's because of something about the way large collections of particles behave together. And that means we haven't explained the arrow of time yet. We've only discovered that it's not where most people think it is. In the next step, we have to face the real culprit, not time, but probability. You've probably heard this argument before. Sure, the laws of physics are reversible, but look around. Cups break, eggs scramble, smoke spreads. We never see the reverse. And that sounds like a perfectly good objection. So, let's take it seriously. Imagine a coffee cup sitting on a table. You knock it off, it hits the floor, and it shatters into 1,000 pieces. Now imagine filming that and running the film backward. The shards leap up, assemble themselves perfectly, and land gently on the table as a pristine cup. Everyone laughs, not because it violates physics, but because it violates experience. Here's the crucial point. The backward version is not forbidden. It's just fantastically unlikely. And unlikely is doing a lot of work here. To see why, we have to talk about what physicists call entropy. Unfortunately, that word scares people, so let's demystify it. Entropy is not disorder in the poetic sense. It's a count, a simple count. It measures how many different microscopic arrangements correspond to the same macroscopic situation. A whole cup is very specific. The atoms have to be arranged just so. There are relatively few ways to be a cup. A pile of shards on the floor? There are astronomically many ways for those atoms to be arranged while still looking like a broken cup. So when the cup falls, nothing mystical happens. The atoms obey the same reversible laws as always, but they move from a very special arrangement to one of an enormous number of less special arrangements. And probability takes over. It's like shuffling a deck of cards. If the deck starts in perfect order and you shuffle it, you get randomness. Could you ever shuffle it back into perfect order by accident? In principle, yes. In practice, you'd be shuffling longer than the age of the universe. Not because it's illegal, because the odds are absurd. The same thing happens when cream mixes into coffee. The laws allow the cream to unmix, molecule by molecule, flowing back into a neat white blob. But there are vastly more mixed arrangements than unmixed ones. So once it's mixed, it stays mixed. This is where people make a subtle mistake. They say entropy increases because time moves forward. It's the other way around. We experience time as moving forward because entropy increases. The direction we call future is simply the direction in which things become more probable, the direction toward more possible arrangements. Nothing is being pushed. Nothing is being dragged. The universe is just wandering, step by step, into regions of higher likelihood. And once it's there, getting back is statistically hopeless. So the broken cup doesn't reassemble itself for the same reason you don't win the lottery every day. The rules allow it, the numbers don't. Irreversibility is not a law of motion. It's a law of large numbers. When you have a few particles, reversals happen all the time. When you have trillions upon trillions, the odds overwhelm you. And this is where the arrow of time starts to appear, not in the equations, but in probability. The universe isn't enforcing a direction. It's drowning all other directions in sheer numerical dominance. Once you see that, time's one-way street stops looking mysterious. It starts looking inevitable. There's a very natural argument people make at this point. They say, all right, maybe cups break because of probability, but I remember the past. I don't remember the future. Surely that means time itself has a direction. It feels convincing because memory feels so immediate. You remember breakfast. You remember yesterday. You remember being younger. And you have absolutely no memories of tomorrow. So let's ask a dangerous question. Is memory evidence of time's direction? Or is it part of the mechanism that creates the feeling of direction? To answer that, we have to remember something uncomfortable. Your memory is a physical process. It's not outside physics. It's made of atoms, neurons, electrical signals, and chemical changes. And that means it has to obey the same rules as everything else. When you form a memory, something irreversible happens. Connections in your brain change. Energy is dissipated. Heat is released. Information is stored by increasing entropy somewhere else. This is not philosophy. It's thermodynamics. You can think of memory as leaving footprints in sand. You walk along the beach and the sand records where you've been. But the footprints don't appear ahead of you. They appear behind you. Why? Not because the beach knows the past. Because making a footprint requires a process that spreads energy and increases disorder. A photograph is the same thing. A notebook is the same thing. A fossil is the same thing. These are not pieces of the past sitting around waiting to be accessed. They are physical scars carried forward. This is where people get confused. They think memory is like rewinding a tape. It isn't. Every time you remember something, you are rebuilding it in the present. That's why memories change. That's why witnesses disagree. That's why nostalgia lies to you so convincingly. You are not looking backward in time when you remember childhood. You are running a simulation now, using information that survived. And that survival has a direction. Information about the past can exist now because the processes that created it dumped entropy elsewhere. Information about the future cannot exist now in the same way because it would require entropy to run backward. This is why memory points in the same direction as entropy, not because time commands it to, because the physical act of remembering is itself irreversible. So when you say, I know time goes forward because I remember the past, you've got it backwards. You remember the past because the universe moves toward higher entropy, and memory is one of the ways it leaves tracks. Here's the aha moment for this section. Memory doesn't reveal time's arrow. It is one of the arrows. Your sense of time flowing is not a separate clock ticking away in your head. It's the accumulation of physical changes that cannot be undone without miraculous coincidence. You feel time moving forward because you are a system that records, compares, and learns, and all of those processes only work in one direction. Once you see that, the mystery shifts again. Time isn't pointing forward because you remember. You remember because the universe has already chosen a direction where records are possible at all. Everyone feels that now is special. Right now feels vivid. The past feels fixed. The future feels uncertain. It's tempting to imagine a bright spotlight sweeping across the universe, illuminating one moment at a time, yesterday fading into darkness, tomorrow waiting its turn. It's a beautiful picture. Physics doesn't use it. In fact, physics doesn't even have a word for now. That's not a joke. If you search through the equations of relativity, mechanics, or quantum theory, you will not find a symbol for the present moment. There's no master clock shouting now for the cosmos. And that's not because physicists forgot to include it. It's because the universe doesn't provide one. Einstein showed us something deeply unsettling. What counts as happening at the same time depends on how you're moving. Two observers in relative motion will disagree about which distant events are simultaneous, and both will be right. This is not a trick. It's measured. It's built into how light and information move. So let's do a thought experiment. Imagine a very long loaf of bread. Space is the length of the loaf. Time is another dimension of it. When you say now, you are taking a slice through the loaf. But here's the catch. If you tilt the knife, you get a different slice. Two observers moving differently through space slice the loaf at different angles. Their nows cut through different sets of events. Neither slice is more correct. They're just different ways of organizing the same loaf. So when someone asks, what is happening right now on a planet a million light years away? The honest answer is, it depends on your motion. That answer makes people uncomfortable because it kills the idea of a universal present. We want the universe to update frame by frame, like a movie. But the universe isn't a movie. It doesn't have frames. The only things that are truly now are local interactions, here, where things can actually affect each other. Your present is defined by what you can interact with, not by some cosmic timestamp. This matters enormously for time intuition. If there is no global now, then time cannot be something sweeping forward everywhere at once. There is no single moment moving through the universe, dragging reality along with it. The present is not a moving edge of existence. It's a perspective. Here's where people often stumble. They say, so the future already exists? Or the past still exists? Those questions are loaded. They sneak human storytelling into physics. Physics doesn't say events exist or don't exist in that sense. It says events are ordered differently depending on motion, and interactions respect causality. That's it. The specialness of now is not written into the universe. It's written into how your brain processes information, locally, sequentially, irreversibly. And here's the realization that usually lands hardest. The present feels special because you can only act locally. You can remember, you can predict, but you can only interact here. So now is not a universal spotlight. It's the point where physics, information, and action meet. Once you see that, time stops looking like a river you're floating down. It starts looking like a vast landscape, and you're not riding through it. You're part of the terrain. At this point, someone always says, fine, time doesn't flow. The laws are reversible. Entropy explains the arrow, but the equations don't forbid going backward. So why can't we build a time machine? That sentence contains a trap. The equations don't forbid it sounds impressive, but physics is not a list of permissions. It's a description of what actually happens in a stubborn universe. There are many things the equations allow that nature never uses. Perfectly rigid rods, frictionless surfaces, a pencil balanced exactly on its tip, all mathematically legal, all physically absurd. Backward time travel usually lives in that category. Yes, there are mathematical solutions, wormholes, closed time-like curves that seem to loop time back on itself. But look closely at what they require: negative energy, perfect stability, exotic matter with properties we have never observed anywhere, at any scale. Not difficult engineering problems, different physics. And here's the pattern that matters. Every time we push the equations hard enough to allow causal loops, something goes unstable. Tiny disturbances grow without bound. Quantum fluctuations explode. Information contradicts itself. Nature seems allergic to causal cheating. People love paradoxes. The grandfather paradox, killing your ancestor and erasing yourself. But paradoxes are not puzzles to be solved. They are warning signs. They tell you your assumptions don't fit together. Physics is extremely conservative about causality. Causes precede effects not because we like the story, but because that structure makes predictions possible at all. If effects could influence their own causes freely, the universe would lose consistency. And consistency, more than elegance, is what nature appears to protect. There's another confusion people fall into. They imagine the past as a place you could visit, a scene frozen somewhere, waiting to be re-entered. But the past is not stored anywhere. It's not a file you can open. What exists are records: photons in flight, fossils in rock, neurons in brains, all of them moving forward, all of them degrading, all of them incomplete. The universe keeps receipts. It does not keep backups. To go backward in time would require reconstructing not just one event, but the entire surrounding universe in exquisite detail. Miss one atom, and you don't return to the past. You return to a different situation entirely. So when people casually say go back, they're imagining a cartoon version of reality, simplified, stable, forgiving. Physics is none of those things. Here's the realization that snaps this into focus. Backward time travel isn't blocked by drama or paradox. It's blocked by instability. The universe doesn't say no with a sign. It says try it, and then refuses to cooperate in every measurable way. And that's not pessimism. That's evidence.